Okay, here we are, lesson 1, Pythagorean theorem review. Pythagorean theorem, you're likely used to seeing a squared plus b squared equals c squared, is used only for right-angled triangles to calculate a length of a side. So Pythagorean theorem is used to calculate a side length only for right triangles. And a squared plus b squared equals c squared is usually what you're used to seeing. Another way to think of this formula would be side squared plus side squared equals the hypotenuse squared. This is because the squares of the two sides added together always equal the hypotenuse squared. And this is because the hypotenuse is always the longest side. We can find the hypotenuse in a right angle triangle by finding the longest side, or if we can't tell by looking at it, the right angle always points to the hypotenuse. So it's important to know where the hypotenuse is because it tells us the longest side of the triangle. And we know the other two sides squared will add up to it. So to use Pythagorean theorem, the first thing we're going to do is identify where the hypotenuse is. So when I look at my examples below, the first thing I'm going to do in question A is to figure out where the hypotenuse is. And that's easy because the right angle is pointing towards my hypotenuse. So I know that the side squared plus the side squared equals the hypotenuse squared. So I can fill in my formula. So when I fill in my formula, when I do an answer using Pythagorean theorem, I'm going to use good math solution and make a nice equation that would look exactly like this. The side squared, 8.6, plus the side squared, 11.4. It's going to equal the hypotenuse squared. And usually rather than put the hypotenuse or put a word, we'll put a letter. I'm just going to use H for hypotenuse. Equals the hypotenuse squared. Once I've got my formula set up, I get out my calculator and I do some calculating. So I actually calculate the side squared plus the side squared. So 8.6 squared plus 11.4 squared would be 203.92. And that's my hypotenuse squared. The next challenge with Pythagorean theorem is I know the hypotenuse squared, but I want to figure out just the length of the hypotenuse. I don't want to know what it is squared. So to get rid of that 2, we do the opposite of squaring. And the opposite of squaring is square root. So I will square root the number I just calculated, 203.92, and that will tell me the length of the hypotenuse. And if you read the question carefully up above, it said to round your answer to 1 decimal place. So when I square rooted, I got 14.28. The 8 beside the 2 is bigger than 5, so it bumps the 2 up to a 3. So I'm going to remember to round properly in my answer. Other things I have to remember in my answer is the units. So I look at my triangle and I see that it is in centimeters, so the hypotenuse is 14.3 centimeters. Other thing I want to remember, since I've rounded my answer, I want to use proper form to show that I've rounded my answer, and that would be a little dot over the equal sign to show that I've rounded my answer correctly. And you've done your first Pythagorean theorem question. B is a little bit different than A. When I look at B, still want to do the first thing, locate the hypotenuse. When I locate the hypotenuse, right angle pointing to it, There's my hypotenuse. This time, however, I already know the length of the hypotenuse. When I know the length of the hypotenuse, that changes things a little bit because I already know the longest side. Since I already know the longest side, I don't need to add two things to get a bigger answer. Since I already know the longest side, I want to get the length of one of the other sides. And one of the other sides is going to be shorter because a hypotenuse has to be the longest. So if I want a smaller answer, rather than add, I'm going to subtract. So I'm going to take my hypotenuse squared, and I'm going to subtract my side squared, and that will equal my other side squared, because I already know the longest side. I don't want to add and get a big answer. I want to subtract and get a smaller one, because the side is shorter than the hypotenuse. So I fill in my formula. 3.5 squared, subtract the side squared, is going to be the other side squared. And the same thing. I don't usually write the word side. I'll put a letter. I can put S for side, you can put A, you can put Q, you can put Z, whatever letter your little heart desires. And then I'm going to do the same as I did before, get out my calculator and calculate. 3.5 squared minus this time 1.8 squared, and I get 9.01 equals the side squared. And same as before, I don't want to know the side squared, I just want to know the side length. So the opposite of squaring is square rooting. So I calculate the square root and figure out the length of my side. So 3 things in my answer. I want to round properly, make sure I have the units and the form. So the square root of 9.01 is 3.0. I look at my question, meters, and because I rounded, I put the little dot. So there we've done a Pythagorean theorem question to calculate the hypotenuse in A, and a Pythagorean theorem question to calculate the length of the side in B. Let's go up and finish our steps. So the first thing was to figure out which side was the hypotenuse. The reason we need to figure out which side is the hypotenuse because that will tell us whether we're going to add or subtract. If there's a number on the hypotenuse, we subtract. If there's no number on the hypotenuse, we add. So our second step is to decide whether to add or subtract. You add to calculate the hypotenuse, and you subtract to calculate a side. And after you decide which one you're doing, you calculate your numbers and leave your answer in good form. I've almost run out of space in good form. And that is everything there is to Pythagorean theorem.